give us your critical parts list. Let's see what we hit. We've had huge hit rates.
Data, we're looking at intelligence, and that comes from people.
But what would that organisation be looking for in terms of duration? If they could max out the design of a product.
Semiconductors tend to have a very short life cycle in comparison.
We're considering durability as like the apex attribute.
How they want to maintain that technology, whether it's we want it to build an application that's going to last for 20 years.
My name is Jon Barrett and I'm the founder of the Sustainable Engineering Alliance. And today I'm in St Neots and I'm at Rochester Electronics headquarters. And I'm with today Stephen Morris, General Manager, and Luke Fitzpatrick, Director, Aerospace and Defence, EMEA. And we're going to take a real deep dive into the sectors of aerospace, mission critical products and defence. And we're going to be looking at the role of sustainability as it's emerging in these sectors. Sustainability is a big subject. It means different things to different people. But in the manufacturing sector and in specifically electronics, and in particular semiconductor, it's all about durability. It's all about keeping products useful and functioning for as long as possible in their applications. So I'm just going to set the scene for Stephen and Luke as I see it. And we're going to explore why the industry functions that way now, how the manufacturing sector is evolving, where Rochester and its services key into that jigsaw now, and how technology is going to evolve that over time. So ultimately, at any manufacturing company, when the employees turn up for work on a Monday morning, what they really want is everything to be pretty much the same as it was when they left on Friday. But that's not how the industry works. The design engineers are going to go into the design department, and at the end of a 3-year design cycle, maybe suddenly their CAD system is going to flag up a component and it's going to say not recommended for new design. That's going to throw a spanner in the works. The shop floor, the surface mount machines, the Kanban systems, they're going to be drawing down components and they might suddenly start to find that they're going low on stock on a particular semiconductor technology and be wondering why. And then in the purchasing department and procurement, they could open an email only to discover that a component is going end of life, or worse still, it's a last time buy notification, or worse still, they've missed the last time buy notification. So I'm going to throw the floor open now to Stephen and Luke, because I'm really interested to know, why does the system work like that? What are the technologies and processes and business systems that mean that's how the system works? My guess is that it's driven by the rapid rate of change in semiconductor design. I could be wrong. There could be other underlying reasons for that. So over to you guys. Tell me why it works that way, and in particular in aerospace.
I think why it works like that, let's just take a minute then to just think about that engineer who's opened that email and it says something's not recommended for new designs, or whether it's something's gone EOL. The point is, at this point, there's completely out of that engineer's control, especially within aerospace and defence. The influence that aerospace and defence used to have on the semiconductor industry was really high. If you go back probably from the 60s onwards, because of the advancements in the semiconductor technology, defence was at the cutting edge. So a lot of the advancements in semiconductor technology was based on the requirements from that sector. These days it's different. And so what that means for our customers in aerospace and defence is that they can't really influence the life cycles of those semiconductors. That's not in all cases. Some manufacturers align themselves with that market, but on the whole, the cutting edge technology is very much now driven by consumer volume as opposed to aerospace and defence applications.
Okay, so essentially what's happened is other sectors have accelerated their rate of change and grown in size beyond the demands of the aerospace sector.
I mean, it's electrification of everything has driven it.
Okay.
Whether that's cars, whether that's homes, whatever it might be, and the volumes that are driven by that, especially if you look at automotive, and I guess telecoms is one of the big ones. The volumes far outweigh. We're talking hundreds of millions, probably billions of devices in some cases going into some handheld applications or into vehicles, whereas with aerospace and defence the volumes are a lot lower. So with electrification of everything has kind of changed the and IoT, I guess, has really changed the landscape.
The fact of the longevity required. If you look at consumer products today, even cars, a car lifetime is 10 years typically in the market space. They need to keep them alive or supported for 15 years. But consumer tends to be very, very quick turnaround. So it just means that it's forcing technology to the next stage. People that buy iPhones or Samsung phones, they're constantly striving for the next level. So that really forces, and that's, as Luke says, that's where the volume is, that's where the driver is, that's where the dollar is. So that has a big influence.
It's interesting. I've often wondered on that particular question. I'd always imagined that the value of those real high-end chips that would end up in aerospace and military would kind of compensate for the volume that you see in the lower value consumer stuff, but that's clearly not the case.
No, I think nowadays you're absolutely right though. I mean, some of the value of these chips are thousands and thousands of dollars, but if they're buying 600 units a year, that doesn't equate to however many consumer units that are out there. So I think it's just the advancement has moved so quickly, especially in the last 20 years, that it just completely outweighs what goes on in the aerospace and defence market.
Interesting. I was wondering about that time frame. You say 20 years is the sort of to have gone from an aerospace derived semiconductor industry to a consumer driven one. You think that's a 20-year sort of time scale that's taken place in?
Well, I think it's probably longer than that. I just thinking in my lifetime being in this industry for almost 30 years, I can see even the major change in that time. But as Luke says, going back to the 1960s where aerospace and defence was very prominent, I think that, coming into just thinking about consumer, early 90s perhaps, really started to take over. So yeah, it's at this stage it's 35, probably 40 years old at this point in terms of the takeover.
Yeah, and the important thing there is actually when you look at some of the designs that are still in production within aerospace and defence and critical applications, the designs were maybe late 80s, certainly 90s, and still continuing to have to produce technology that was designed back then.
Right.
It's that's the major challenge, and that's, I guess, why we're here to support.
Yeah, just to throw down some sort of numbers. When a design is laid down in an aerospace or defence environment, in an ideal world, I can appreciate that eventually technology will supersede and a circuit will have to move on at some point. But what would that organisation be looking for in terms of duration? If they could max out the design of a product, ideally, what are they looking for? Is it 20 years, 30 years, 40 years?
I think it's all of the above. I think that, yeah. I think that it depends on the end applications.
Right.
If you look at aerospace, in terms of an aerospace platform and all of the investment that kind of goes into the front end, they're looking at a 40-odd year life cycle of that to actually make the whole program profitable for a certain amount of time, because there's tens of years that go into the research and development beforehand. So yeah, that's a long program. Then you've got within aerospace, within defence, you've probably got some shorter life cycles as well. But it all depends on the application, the customer, and how they want to maintain that technology. Whether it's we want it to build an application that's going to last for 20 years, and then the commercial objective of that organization, be it a prime contractor, is to then sell the next latest and greatest onto the end customer, or whether it's a technology which they want to maintain for a certain amount of time, because there's the time and effort that will go into redesigning the new latest and greatest wouldn't be worthwhile. So they just want to maintain that specific project and sell it for 20, 30, 40 years. But it's all down to often it's down to the objectives and the goals of the prime contractor and the requirement of the end customer. If the end customer wants to, let's just say it's aerospace, and you've got this comes down to a conversation that we have with our customers quite often, which is the difference between a forced redesign and a strategic redesign. So if you say, for example, an aircraft infotainment system, you may have a requirement every, let's say, 10 years to update that, because it's down to consumer experience. So that system on that avionics platform, they'll want to update every 10 years just to keep up with everybody else. Whereas on the same aircraft, you could have a refueling panel in a wing of an aircraft, which was designed in the 90s. No need to upgrade that technology. Doesn't need to do anything different than it does today. But it might have some custom ASIC parts within that application. Nobody wants to redesign that. There's no value in redesigning that. They don't need it to be faster, quicker, do anything other than it's doing today. So then the objective of that specific application is to last as long as that platform lasts for, the aircraft. So it can really depend on commercial objectives as well as the type of application that it is.
The adder to that is that the fundamental, so if you've got a design cycle where we talk about 10 years, a 5-year design cycle, say, flight, they've got to do flight tests, they've got to do, the whole regulatory side of it for safety, obviously. Semiconductors tend to have a very short life cycle in comparison. Say it's 10 years as an average for semiconductor life cycle. The time you design a new part into the point that you launch that product that you then have to look after or keep in the market for 35, 40 years, the silicon's then old. Mm-hmm. So they have that problem right from the very beginning. So that's a fundamental part of that. And it's also, I think, it's where it's uncontrollable. They can't control that element. So from a sourcing point of view, they're relying on their suppliers continue to supply for them for the life of that product. And that's really difficult. That's really hard.
And so in that model, as it sits at the moment, where you could be looking at 40-year life cycles for some products, say fuel systems, that type of thing, slightly shorter for entertainment, and you're saying you think semiconductor averaging 10 years, do you think?
Yeah, I think as a broad average, I would say. Some are shorter, some are longer. I mean, some they do like a grandfathering process where they then start to scale down and then they'll support so many customers, etc. But that goes back to the original point where their volumes are not high. So even though these are big global organizations, they don't have the spending power then to keep the interest of the semiconductor manufacturers. So it then becomes problematic.
I found it interesting during the pandemic period where big industries were trying to influence semiconductor manufacturers to focus on their needs. But even the automotive sector, for example, wasn't big enough to outweigh the demands of consumer laptops and things. I found that really interesting. I thought it was a real kind of eye-opener.
But you can see how quickly an environment changes something, or where these big consumer companies, because during lockdown, people were at home. We needed PCs, people were buying new phones, they had money to spend because they weren't travelling, they weren't spending the same level of money. They needed technology in their house, people were buying PlayStations and TVs, and that's where a lot of the spend was going, that's where a lot of the capacity was going. And quite quickly, the semiconductor manufacturers were saying, well, they don't ultimately care where it comes from, so they focused on that. And you're absolutely right, the automotive sector, where they've got a good handle and a good influence on the market, couldn't touch the sides of it. And that was surprising. It was surprising for them.
Yes.
It was a bit of a shock, I think. But that's changed the dynamics of that whole market as well today.
Yeah. That's fascinating. The the question I've got now really is, we've kind of set the scene in terms of semiconductor availability. Best case scenario, your design drops just as a new semiconductor is released. You might make it to 10 years. Aerospace sector, kind of worst case scenario, you're halfway through your design cycle when a do not design, not recommended for new design kicks in, and you're looking at 40 years to try and extend the durability and life of that product. Given that time frame, where do you guys fit? Okay, where do you slot in terms of that timeline, and how does your service dovetail with that and make that achievable? What do you do? How do you do that?
I think for us, it comes down to obsolescence management and how the customer does that, depending on their application. The best practice in obsolescence management starts at design, so right at the front end. For us as a business, in terms of where we are today and from a technology capability and license manufacturing side of our organisation, we're driven by obviously by obsolescence, but in terms of our investment, we can also be driven by the types of technology that are important to our customers. So if we understand at the front end that a customer is building in a critical processor into their program, they're going to need that program to last for 30 years, and they're at the beginning of that journey. Rochester understanding that customer, what technology is important to that customer at that time, can help us through the process and the life cycle of that semiconductor, help us invest in the right places, whether that be capability, whether that be at obsolescence stage, acquiring finished products, whether that be acquiring the license to continue to manufacture that product for the life cycle of the customer's application. Knowing that at the front end and being able to have those informed conversations with the customer, but also with the original component manufacturer, to set the scene and see whether there's the possibility of that extension of life, is critical. So in terms of where we start, for me, that's right at the beginning.
Yeah. I'll ask a tricky question now. So I went through a formal design education many years ago. I won't say quite how many. That type of subject, planning for that type of thing, that was not part of my syllabus. It didn't even come close. So how prepared is the design community to have those conversations right now? Is it dependent upon the sector they're in, I guess, to a certain extent? Do you know if there's formal education in that as a subject? I know there are a lot of associations now trying hard. In fact, I'm doing a presentation with one of those in a few weeks, that are trying to raise awareness of that subject amongst the design community. What advice would you give the design community in terms of sort of raising their awareness and getting involved early with that?
I think that when it comes to design, in my experience, and I did a talk at the MOD a couple of weeks back on the topic, and a lot of it depends on the resource, and a lot of the design engineers, their time or what they're paid to do, their cost center is to design the new product in terms of what's to come and the future of that product, not necessarily their concern at that point in terms of their role. So it's really from a project standpoint that the obsolescence management needs to start, and whether that be a type of design, whether that be a modular type of design where they can actually think about obsolescence. Okay, if something goes obsolete in this module, we can replace it, that's great. Or we've got a few different designs in play here, so that actually if one goes obsolete, if there's a critical part there, we can move over to the other one. Or whether it's contingency planning in terms of funding, putting funding aside for the last time purchase or for the redesign or for whatever it is the objective is of that program. But I think the challenge is often resource at design stage. But that's where we try to engage. And one of the topics of the talk I did at the MOD was around looking back to think forward, which was learning lessons from the past. these types of applications. You may have the Tornado aircraft, which has long gone out of service now. But what lessons were learnt from between Tornado and the Typhoon aircraft? There's one chap at the MOD, actually. He made a great from the MOD. He made a great example. He said the flight control computer in the Tornado was in the center of the aircraft, and to get to that flight control computer, they basically had to take the aircraft apart. And when they designed Typhoon, where did they put the flight control computer initially? Right in the center of the aircraft. So you'd have had to take that apart to get to the flight control computer. And the point was that in the Tornado, that flight control computer had to be, because of obsolescence, replaced 3 times over the life of the aircraft. So when it came to Typhoon, they said, well, we know what's coming. Semiconductor technology is going to move on, and we are going to need to address that. So why put it where it's a pain to get to it? Let's learn from the mistakes. So I think that's a huge part of it, actually, looking back to see what they say. Success leaves clues. I read a lot of books that contain that sort of terminology, but so does failure. And actually learning from lessons and mistakes that were made, I think can really help in the long-term planning at design stage as well.
On the subject of design, you mentioned modularity. In the matrix of sort of sustainability attributes, we're considering durability as like the apex attribute. Everything should target durability where possible. However, as you exactly said then, durability is often influenced by design for modularity, design for integration, most importantly, design for disassembly and repair. Even if you're at circuit board level, how do you remove a device? How do you add a device? Or is it disassemblable, as you say, in modular fashion? So those are subjects that fascinate us. It sounds like it fascinates you guys too. So as these podcasts evolve, be interesting to follow on and look for examples of how that's working. The Tornado and Eurofighter example there, absolutely perfect. On that note, you may not be able to answer this, but one thing I'm interested in, they've learned a valuable lesson there of how they can improve the design of the aircraft. Is that information being captured in their design process so that the next time round it's part of it automatically? They don't have to think about that again. It's built into their kind of CAD infrastructure almost, or their design strategy.
That's a hard one. You'd have to get to system level to understand that, I think. But in that previous story where we're talking about Tornado and Typhoon, the fact is that something was done for someone to turn around and say, well, hang on a second, we've done that before and that didn't work. So I think at the very beginning, it probably wasn't captured, and the mistakes do happen again. But it's tough from the engineering and design standpoint, because if we think about what are their tools at design stage, they know what worked last time. Do they want to use that again? What's the life cycle of that component that worked last time? Is it at risk to use that again? Where are they getting their data from? Are they using the online portals, which there's many of them, which will give years to end of life, or however it's framed these days, but 5 years to end of life, not recommended for new designs. Those that data is static. That data is in line and parallel with the roadmaps from the component manufacturers. So it will be very much what the manufacturers want the design engineers to see. Is it a true reflection of the exact risk? We know that obsolescence can happen for many different reasons, and I think that's kind of one of the big things when we're talking to customers is to really truly manage obsolescence properly. You need to understand the causes of obsolescence, whether that be the foundries and a change at the foundry, or whether that be lead frame manufacturers. It could be a strategic decision by the original component manufacturer. But if you understand the reasons for that obsolescence, actually then you can, or the drivers for obsolescence, you can then see things coming. No one has a crystal ball necessarily, but the market works in cycles. Obsolescence comes at a certain point within the market, within the cycle. So if you're constantly, as Rochester are, if you're constantly engaging with the original component manufacturers, the foundries, because we're manufacturing, the lead frame manufacturers, we start to hear things in terms of, okay, what's their roadmap? And if the packaging roadmap, the roadmap for the packaging manufacturer is this type of lead frame technology as an example, if they're moving out of that in 2 years, but on the other hand, the life cycle of that component, according to the original component manufacturers, is 5 years, there's a mismatch there. And it's where it starts to leave clues, and I think that's where, with Rochester Electronics, with our roadmap in terms of our manufacturing capability, you can see that if we're in the next 5 years looking to manufacture a certain type of lead frame or a certain type of package, it's because we see something coming.
Stephen, passing that question over to yourself, where we've spoken about this in the past. Obviously a critical thing for our viewers to know is, as Luke just explained, your manufacturing capability, because that clearly puts you in a different category of organisation. Now, making a semiconductor product is not trivial. And as Luke just alluded to there, you've got the silicon, you've got the lead frame, you've got the package, and probably most important, you've got the test.
100%. Yep.
Can you just give us an indication of how that process works from Rochester's perspective? You know, how do you manage that process?
So I think it depends on what we're manufacturing, because there's the different levels that we get involved in. Obviously, Rochester can manage from die up, so even manufacturing the die through third parties, we can do. I think the key thing is that it's the key relationships that we've got with our suppliers that allows us access, to die itself. But the test part of it is a big thing. We call it IP. They call it, IP transfer. So from the point that we've identified that there's maybe a product that we want to get involved in, can we get the die from the manufacturer? Yes, tick. We can get the die. Can we get the IP transfer, the test program transfer? Yes, we can. So then we're looking at lead frames. We're looking at packaging. What do we need to do to test? Do we need to update the test systems that we've got? It might be a package that we've never manufactured before. And one of the things that Rochester is now doing more and more of is a lot of the manufacturing of the packaging in-house. So, a decade or so ago, we would have put a lot of that stuff out to the field, but now we're pulling it back in because fundamentally we are the only people that can do this now. So it's important for us to hold that. So all these things have to get put in the mixing bowl. And we determine then, can we do this? And again, the IP comes directly from the manufacturer, because everything we do is under them, is 100% from them, authorised. So we don't do anything on our own in that sense. But what it does mean is that everything we do then manufacture as it would be as the original part was. And I could sometimes say flaws and all, right? Because sometimes there are silicon issues that they have that, are no majors, but it means that we design exactly the same. So when Luke's talking about some of these programs where we then put a part on the board, it will work exactly the same as the original part. So that manufacturing process, as you say, is not easy, but what our intention is with it is for us to basically put a product back into that board with a Rochester badge on it that works exactly the same as the original part was. So it means from a redesign, requalification. We have, for example, customer, aeronautical customer, flight control system. We've taken a part that was going obsolete. Again, we worked with the OCM. We brought the technology over. We manufactured the parts for the customer, which we developed in about 12 months. And they didn't have to go through flight trials, which was a major for them. because I can't remember, but the time, is the years and the money that would have been involved in that was just major, and that could have been a make or break for them. So now there's obviously aircraft out there with our parts on board that are doing the job that all of the parts have always done. So for them, the amount of time and effort that it saved them. Luke talked earlier about design resource, where resource is used for new design. That's the valuable end of what these guys are not paid to do repair or paid to, redesign a board again because they can't get parts. So that's really important. So the amount of overall time and money that we saved that particular customer was huge.
Your comments there are questions are firing in my head now. I'm imagining you guys now with the packaging, with the lead frames, with the test equipment, because the test equipment will be going obsolete. Absolutely. Over time as well, and I know a lot of labs, the things they cover the most is their legacy test equipment. You're almost, I don't know how to describe it, you're almost becoming a vertically integrated semiconductor manufacturer like the olden days.
On our own right.
So keeping control as necessary of those processes. You talked about errors in semiconductors. I don't think there are many semiconductors that don't have an addendum of some description. And so what you're saying there, just to clarify this for our viewers, if an engineering team has worked through a design and worked with those addendums, then their platform will be engineered for that operation. And so the badged product is it actually badged Rochester?
It
is. Yeah, okay.
Yeah, absolutely.
Yeah, that's right.
I should look at some boards really and have a look at the badge. Okay.
The important thing there, though, John, is that the part, because we're doing it under license, and that really is an important piece to this, because the manufacturer's part number is the same.
Okay.
So for them, from a customer's perspective, all they have to do is qualify Rochester as a manufacturer, and pleased to say that we are with most of our prime customers. But it's that the fact that the part number is the same means also no redesign or requalification of that part on that board. It's just a different source, and it may be with the first delivery that there's first article inspection or whatever it might take for that approval process. But it's exactly the same part. Other people can recreate a part that does the same, but again, to your point there about having all of the addendum and all of the things that the original manufacturer had to go through to get it right, we're privy to all of that, and the part number's the same. So for the customer, it's lower risk.
But that's where the engineering part comes in, as you say. Look, if you've got a part that's copy paste, what they think is copy paste or a recreation, all you need is track lengths, track widths, capacitance, resistance to change within that piece of silicon, and it can have a huge knock-on effect on timing on a circuit. Say that timing on a flight control system that doesn't work quite properly, you might fall over in every 1,000th flight or whatever it might be, but that can be absolutely catastrophic. So for us, that's a really key point, is that we're not recreating something that looks similar and fit, form and function. Yes, absolute fit, form and function, but they are as the original pieces of silicon. That's what's important. And even if you've got errata on die revisions, we're making that die revision because that's what the customer needs and that's what they want. So we're not just taking the latest and saying, right, we'll just give you the latest one, because quite often they can't use it. And that's another complexity that comes into, if you've got a system that's been in the market for 30 years and parts go obsolete, but they say, okay, but there's newer versions available, but we can't use it. So that's another important part of this whole process. So it's to try and take away the risk involved. We eliminate that risk, especially when it comes to other people who do recreation.
Yeah, so this is a risk management process at its very heart, isn't it?
Yeah.
I'll just throw an anecdote of my own in here, because I thought I knew this industry relatively well in terms of the effort required to go into the redesign of an aerospace product. Until I attended Arena Compliance Conference a few years ago, and there was a presentation given by an aerospace company there. I can't recall who it was, But they'd been forced into a redesign of a product. And when they quoted the sums of money, because they were quite open about how much they thought the budget was going to be and the amount of time it was going to take, I thought they'd got the numbers one order of magnitude wrong, too big.
Yeah.
They were mind-boggling sums of money and amounts of time.
Yeah, that's right. And do you know what's interesting about that also is the proportion of that. I think if we went back 20 years ago, you'd see the proportion of that sum and the time would be 80% hardware and 20% software. Now you're probably looking, from a redesign on a current system, you're probably looking at 70% software and 30% hardware. So it's really flipped on its head over time, right, in terms of the time that it takes and the cost.
That's interesting. So yeah, because one of the things I was going to ask again about durability, and I'm thinking what's driving my thoughts on this is what's happening in the automotive sector, which may be being mirrored in aerospace and defence. I would imagine it is, which is the software defined system, where you want to fix your hardware and then evolve the product through software over time. So that's going to place even more pressure on the availability of those components over time, because there's very little incentive to redesign the hardware if the hardware's role is to accept flexible software. And I can see this happening certainly from the electric vehicle manufacturers, where that industry's kind of been flipped into a software-defined vehicle, and I'm imagining that must apply to a certain extent in aerospace and defence environments as well. So I can see that adding more pressure to the hardware durability.
Yeah, absolutely.
But from a hardware point of view, we talked about it briefly earlier, but the modularity of hardware design. If you look at automotive, it's all about modularity and platform. And that allows them to build en masse. It keeps the cost down because it's over several product types. But it puts pressure on that module, that hardware, because if something, I think you mentioned it earlier, if something goes wrong, it has a bigger impact. But you're right, it's getting the stability of then having a stable platform that they can build upon, but not build upon with hardware, but with software. And again, that just means that they have to be able to support that for a longer period of time. So I think that's the challenge that we're coming into. We're starting to see that, the automotive market are talking about these things now, where they're saying, right, how do we ensure that we can keep these things alive for the next 15, 20 years? And, that's the conversational piece that we have at the moment. And I think the automotive market have got to that point very, very quickly because of what happened during the shortage period, when we had that period where people wouldn't listen to them and they said, but we need semiconductors, sorry, we're building PlayStations. So that had a huge impact. And I think what it has done in the market space is companies or areas like aerospace have been looking at it, think we don't want to be impacted like that too. So that it's made their thought process change in terms of how they do hardware design and how they evolve their products.
We're talking different industry sectors, different volumes, different values, all creating this kind of web of activity. Just from an interest point of view, and you may be able to tell me this or not, what would be the lowest volume product that you would manufacture versus the highest volume? What's your window?
That's a big window
of activity? Have you ever made just one?
Well,
10, 100.
We manufacture. We have manufactured product for a customer, which obviously economies of scale and cost change during that process, but we will support. Typically our business is low volume, high mix, but again, that's evolving and changing now because we can see that there's more need for longevity, which means that they want to keep things alive for longer but at a larger volume. So that's something that we're looking at, because maybe not necessarily the aerospace defence market, because as we said earlier, they tend to be lower volume, but as a business we've identified that this is another key area for us, so that it won't always be for all customers, low volume, high mix. There will be the time where they'll want, maybe let's call it medium volume, where we would get involved in that, but we need to supply for the next 15-20 years. So I can see that as next stage for us, and it's certainly something that the business is taking on board now and looking at and putting plans in place moving forward.
We're going to focus in on mission critical applications. There's obviously overlap there with aerospace and defence. We're going to focus in on some defence activity and use that to sort of segue into electrification as a mega trend. And then we're going to take a look at a kind of checklist, really. What are the sorts of things that the design engineering team should be ticking off on their design plan at an early stage to help manage the durability and longevity of their products? And conversely, what should be the checklist for legacy support and also forced redesigns should they be necessary? So I'm going to start initially, I think, with defence, and I'm going to throw in an anecdote here. I typically attend the DSCI show each year. I know you guys are going to be there this year. We're going to come and have a look at the stand, maybe do some product, so explore some of the products and services on stand and take a closer look there. Now, last time I was there, what I did notice was an awful lot of activity in autonomous aircraft, typically drones. For a whole variety of tasks, I saw some very big machines that were being used for fuel deployment, surveillance, and that type of thing. And what fascinates me there, and I'm pretty sure you guys are going to be able to answer this for me, is what the sort of compliance rules are and the regulations and standards around that type of aviation system. I imagine if I go into a model shop and I buy a model drone, I doubt whether that's going to have gone through some regulatory process. But once these things start to scale up, I imagine that type of traceability and regulation kicks in, and thus durability and longevity and sustainability starts to then play a role. So fill me in on that as a subject. How is that working, and what comes next?
I'll be honest, it's a journey that we're on as well in terms of our understanding there. I think we've seen in terms of defence capability with the theatre that's currently between Ukraine and Russia. I think drones have played a huge part in that. I think there's different types of drones at play, and I think that the different types of drones may have different certification requirements. I was with a customer in Madrid last week who's a manufacturer of drones, and it was a question that I asked. And the certifications, the drones that they're building are surveillance drones. And looking at them, you would think there's someone in that aircraft. They're that big. So they're kind of fast jet type size. And my question was, in terms of certification, is it like for example, in the UK, the Civil Aviation Authority, do they have to go through all of the regulatory qualifications? And the answer was yes on that, but there was different types of certifications, and often that's determined by the end customer and their ultimate use for that aircraft or that drone. So we're learning. I think there's a scope of different types of drone, which some will require, some won't. As you said, you go to a hobby store or a remote control aircraft store, whatever you like to call it, and buy one, then you're not going to have the same regulations as one of these larger type of platforms which require the full types of certification. And I imagine that there's steps along the way and everywhere in between. But it's certainly every defence show that you go to, even being at Le Bourget, the Paris Air Show a couple of weeks ago, Again, a huge presence in terms of some of the drone manufacturers. So it's an area for us to explore more, but obviously if they're going through on the larger type drones, if they're going through the qualification processes that they have to, that civil aviation has to, then of course there's going to be a drive to maintain systems for a certain amount of time, because with requalification of new parts, new systems, comes cost and time. So obsolescence is going to play a part in those, I would say, the higher end type of application, as opposed to the lower end, which is recreational use types of drones, which I think are also being utilised in some conflicts today. So it's I think it's a big market from small to high end, but certainly on the high end there's going to be an obsolescence or a sustainability challenge there for sure.
Yeah, so clearly it's scale and value and again certification that plays that key role. I'll kind of drift off slightly on subject, but not too far, because the drone activity is part of the electrification of everything. With the electrification of everything comes a blurring of lines, should I say, between electrical engineering and electronics, in a way that maybe is new to many industries. One manifestation of that, again with defence applications, is sort of humanoid robotics and that type of thing. I'm unfamiliar in terms of the value of those types of kit and the expected life cycles. I'm wondering whether any of that may fit in, maybe not. Too short term potentially, but do let us know. We're thinking the Boston Dynamics type robots that I'm seeing working in factories as sensor arrays and that type of thing. I'm not sure about the value of the semiconductors in those products.
I think it depends on use case, but interestingly, the US robotics being used for useful function in manufacturing or whatever it might be. I mean, if you look at robotics within manufacturing, there's a huge need to keep those things alive for a long period of time. Big investments in those in the equipment. So again, that's another area where the longevity of supply of semiconductors into those market segments is critical. So I think it'll be interesting to see how this grows, how it spans out. I think there'll be probably new regulations that pop up, because I think there'll be a requirement, whether it's at drone level, whether it's at robotic level, and probably both, and how we get involved in that. I think what's interesting for us is the fact that we're at the beginning of this journey, and a lot of what we do today is we tend to get involved mid-ground or at the back end, whereas this really means that we can get involved at the front end and start discussing with these companies and how we can help them sustain the life of their product.
Yeah, interesting. Yeah, I've talked to some robotics companies and engineers recently, and it is an interesting subject because, as you say, it's undefined in many instances. In particular, the level of kind of regulation for a robot that's allowed to work in the proximity of a human versus one that would work in a staged, safe area. Yeah. So I'm imagining that as these roll out over time, so this is a future issue really, I guess, that the regulatory infrastructure will start to form around humanoid robots that are allowed to work in proximity, pushing up the desire to keep those designs stable for longer.
I mean, I think it's interesting because if you think about robots, the basic principle of robot, where you've got elevators that are fundamentally robots that take you up and down, right, or escalators, they're highly regulated because they move people. And it's interesting you say, I've never actually thought about that idea of the proximity of robots working with people, and that brings a whole level of safety regulation, which means it'll be much stricter. And again, it's an environmental thing, what the end function is, etc. But yeah, it's almost, I suppose, medical-like in a way as well, because it becomes critical that it doesn't fail, because failure could mean death for someone, and that has a huge impact. So that's why I say I think there might be addendums to certifications that or regulations that will start to come out of that. And again, it'll be interesting to see. But yeah, I think it's a bit of a journey for everyone on that front.
I recall having a conversation with an automation team that manufactured the hand controls for robots. So if it was a fixed installation and it was being manually controlled by a tethered control, I'm pretty sure that was regulated, because you didn't want an interaction with that hand tool putting the robot out of control effectively. I'd have to check that, but there may be a regulatory environment around that.
Well, probably limitations
you could look at.
Yeah, there'll be regulations and limitations to what you can do under certain fixed regulations, because that's why regulations are there, right?
Yeah.
So it'll be interesting to see, because again, it's use case, because there'll be a lot more use cases for these things now than there was 10, 15 years ago when we didn't have that level of technology. So as I say, I think it's a bit of a journey for everyone, but certainly for us, it allows us to get involved at the start, knowing that they will need to keep these alive for 10, 15, 20 years, which is exactly the sweet spot for us.
Right. That is the sweet spot, is it? I was wondering, is there a sweet spot in terms of,
I think,
where it's...
Yeah, I mean, I don't think from a timeline point of view, I wouldn't say, 15 years is our sweet spot. Anything beyond the typical life cycle of semiconductor in areas that require much longer, production of a product, or certainly something keeping alive in the market, is where we come in, because typically, traditional semiconductor supplies can't do that, and it forces redesign. As we've talked about before, it just forces that cycle, a never-ending cycle of redesign. So I don't think there's a particular sweet spot. It's just the fact that we can go right from the beginning of that whole design process all the way through to the very, very end. And and our involvement has different impacts with different customers, but we see it obviously as essential. But I think we can add a lot of value into that design chain.
I think also there's something which we haven't mentioned, which is the way that we support through the market swings in terms of the semiconductor cycle and shortages. Because not only do we have the manufacturing capability and the licensed manufacturing side of our business, we're also a stocking distributor. All of our stock obviously comes directly from the factory, so it's 100% authorized, as is our manufacturing. But we acquire stock over time, active stock as well as obsolescence. So we have active stock which the manufacturer may have had a higher yield than they thought, and have factory stock, and shareholders are thinking, we don't want that asset. Where does that stock go? That comes to Rochester. So we've got active stock to support the shortage market as well as when obsolescence comes. And that's part of our relationship and our agreements with the original component manufacturers as well.
Excellent. Yeah, that's worth knowing. Going back to the core subject of sustainability and moving on to the subject of sort of critical infrastructure, I was involved in writing about a project a few months ago about the design of a new rail bridge. Now, any piece of equipment used in a railway is going to be heavily regulated in its design and operation. This is a groundbreaking design. It was fascinating. I went to see the first prototype. It's a new design of footbridge, but it includes electrical and electronic systems. It's got lifts, it's got lighting, etc. And you were talking about lifts earlier on as robotic systems, heavily regulated. Integrated into that particular design. Now, it's a fascinating design. I won't go into too much detail, but it's modular, as we were talking about earlier. So if a part is damaged, it can be replaced. It's stainless steel, so it doesn't need to be painted, and there's no issues with corrosion. It's bolted together, not welded together, so it can be assembled on site and disassembled for maintenance. But the thing that really shocked me was that this project has the bridge with a design life of 125 years. And that's got electromechanical systems in it, regulated, that are going to have to travel along with that product's life cycle. That's 5 generations of engineers.
That's huge.
Yeah, by the time you get to that, there's going to be no one around who even knew why it was designed.
Yeah.
So in terms of that type of embedded sustainability, I'm seeing a lot of that now at blue chip OEMs and that sort of thing. So I'm guessing that's the type of project that the future Rochester is going to be supporting. Would I be correct in saying that? Is that the type of...
Yeah, absolutely. I mean, that's I didn't know that existed. So, I mean, that type of thing where 125 years is, everyone might think, well, that's just impossible, or it's way out there, but it's not. I mean, we get asked quite often in different sectors, we need 50 years, we need 60 years, and we're like, wow, and that's to support current semiconductors in their market space. That's momentous in terms of how do we do that, how do other companies do this. We're quite unique in that instance where we say, okay, let's have a look at it, let's understand your systems, let's understand what your future needs are going to be. So it's important for us, again, at that stage, to engage with the customer to understand where their critical parts are, what's critical. If something goes wrong tomorrow, what has a big impact on their system? So for us to get engaged with the customer at that level means that we stand a fighting chance of helping support them through that longevity, whether it's 10 years, 50 years, or 125 years.
Mm-hmm. And so in terms of critical components, so we'll focus in on that. Imagine a standard bill of materials. It's pretty big, even for a basic product. For some complex boards, it's potentially thousands of rows. Out of all of that data, how do you identify? I can imagine there might be one big microprocessor or microcontroller or ASIC at the center that you can say, without a shadow of doubt, that's obvious. Yeah. But where are all the other critical components hidden on that board? Do the designers know? Do you guys know? Is it a collaboration that identifies them? What's the best way
I would say that
of doing that?
No one should know better than the designers themselves. The easy way that we try to explain it to some customers is, if something was to go obsolete tomorrow, would it be a headache in terms of hardware or software redesign? And I know that's very simplistic, but by a headache you mean, is there going to be some element of redesign around it? Is it single source? It's another risk factor there. So, but we certainly have an idea, and I think what some of our customers will say is, well, okay, this processor, this is the heart, this is the brains, but actually around that, whether it be power or memory is a great example, because the impact that AI is having on memory with the HBM type of technology which is coming into the market means that something's going to have to give way in terms of the capacity that's there to manufacture memory. DDR3 we're seeing is already kind of legacy, but if you look at the investments that NVIDIA have made in the HBM memory with SK Hynix and Samsung and Micron, they've invested billions into that type of technology. And I think in terms of DDR3, SK Hynix and Samsung have already announced that they're removing themselves from it. Micron are the only remaining manufacturer of that type of technology. Micron can't fill the gap that the others had. So we can see that type of technology having an impact on the board. Would memory be a critical part to our customers? Don't know. Depends on which way they look at it. Maybe they have drop-in replacements, and if they have multiple different lines designed in for the same slot. But it's just an example of it. Doesn't necessarily need to be the processor. It can be.
Yes. Okay. That triggers another question, which is, can you give me an indication of the breadth of technologies that kind of come under your umbrella? I mean, we spoke there about micros, spoken already about ASICs. You were talking then about memory. You mentioned power. How wide does that umbrella go in terms of distinct semiconductor types?
We go all the way from diode level, transistor level, all the way through to complex ASIC.
Right.
So I would say full breadth. Does it cover every single element of technology? Probably not. But we've got a lot of stock of parts. We're a a 15 billion part stockist, right? I mean, that's quite a few components to have. But it's also the manufacturing capability that we have, which tends to come around processor base, because that tends to be the sticky heart of a system that needs replacing. So yeah, I mean, our coverage is wide. It's not just one particular area, but anything that's semiconductor based is what Rochester is all about.
FPGAs?
Yep. So FPGA in its original form. Sometimes we look at FPGA to ASIC conversion thing that we've seen people that are struggling with sort of older 3 volt, 5 volt technology, and that's something that we would get involved in, is looking at that as an FPGA to ASIC conversion for the customer.
One of the things that we have spoken about briefly before certainly applies to aerospace and defence is the rate of order placement for new equipment, so new aircraft, weaponry, vehicles, systems, etc. Because there's already a pipeline full of production. So these are essentially back orders. Every time a back order goes into place for a system that is certified, then ultimately the whole sustainability picture just grows almost exponentially, pushing that product even further into the future, and compounding the effort required to do that. So just give me an idea at the moment as to the state of, how can I put it, the back ordering process in both those sectors. What scale is it at? How full is that pipeline? And what does that mean for extended support?
I think if we start with aerospace. So aerospace and defence we have to understand the drivers for the volume going into those sectors. So aerospace growth, it continues to grow. The growth in aerospace is coming from consumer demand for air travel. But what's interesting is it's where that's coming from. That's coming from countries which the GDP is growing, developing countries who are essentially flying for the first time. So that's actually where the growth in global aviation is coming from. If you were to give everyone globally £10,000, for us where we are today, air travel is the norm. We wouldn't necessarily take another flight. For people in other countries, which developing countries, that's exactly what they would do. So actually air travel, as those countries are developing, is becoming more demand for it. The back order process is, if you think about some of the most common platforms, narrow body and wide body, the backlog is extending. So in some cases 10 years and beyond. There's no new platform really in terms of propulsion. The next generation, what's it going to be? Electric, hydrogen? Is it going to be hybrid? That's not really defined, and no one's taken that leap on the next technology yet. So what that means is all of the orders that are coming in are being put into the backlog. And obviously, if you're already looking at a 10-year backlog, with every Paris Air Show, with every Farnborough Air Show, the backlog it grows as the orders come in. And those systems, those critical systems, need to be extended. As we said earlier on in the podcast, we said that there may be strategic redesigns on some of those programs if it's infotainment. But actually, there's an awful lot of systems, hundreds of systems in these aircrafts where they don't want to have to redesign, so they want to maintain the existing design for extended periods. So from 10 years, we've been contacted by our aviation customers saying, we now need to extend. We need more safety stock, and whether we can provide that through a stocking solution where we have the stock, or whether it's a manufacturing solution, it's a regular occurrence for us. So that's the aerospace side. On defence, it's obviously driven by, it's not consumer demand. It's driven by ongoing theatres, new theatres popping up, and geopolitical threat. And again, that's driving. We mentioned infrastructure earlier on, and the increase in countries' GDP being spent on defence is growing. I think there's targets of 2.5% now 3%, looking at 5% now. And a lot of this additional spend will go on new technology and research. It will go on infrastructure. A big percentage of that, I think, will go on infrastructure, but also on securing the nations today, and that's where extension of existing programs is going to have an impact on that as well.
Yeah, interesting. As we draw towards the end of this session, what I'd like to start doing now is leaving viewers with some kind of checklists, really. So we're talking about early engagement as the kind of gold standard for getting this right. So there's obviously things that design engineers can be doing at the start of a new design project, regardless of how long that project will last. But in addition to that, there's another group of engineers, and they're dealing with existing legacy systems in terms of supporting those, and also potentially being forced into an unexpected redesign. So I'm wondering if we could put together two sort of relatively simple checklists for those two groups of people, and see again how your services sort of dovetail into both of those. So should we start with new designs? So imagine a team is sitting down, reasonably clean sheet of paper. They've got some specifications, some design goals, some ideas, and they're ready to roll. What should the checklist be in terms of sustainability, durability, and the engagement of someone like Rochester?
I think for me, if we step back slightly, because this is something that goes across both the examples that you gave, new design and support of legacy systems, I think finding value in the supply chain is key. I think in the semiconductor and the distribution market over the last 5 or so years, through the market cycle with the shortages, I think a lot of people approved a lot of suppliers, and their distribution network is now huge, and I think that's diluted some of the value. I think that customers and system manufacturers would do well to find the value in the supply chain and then double down with those suppliers, and really extract every bit of value out of them that they possibly can, whether that's a Rochester solution or another solution or design partners or whoever it might be, just finding the value. I think on the design side, it's engaging early. It's a lot of it might actually come from the commercial side of the engagement with the end customer. Does the end customer want? Is there something contractually in the contract where it says that actually longevity, sustainability, durability is built into a contract commercially? That's kind of, if I'm thinking about the end customer being the Ministry of Defense as an example, something that they're doing very well within the DoD in the US is driving some of this wording into contracts right at the top level, so that it flows down through the supply chain, so that there's a better chance that obsolescence is managed in the right way. So I think it can start there. But in terms of new designs, I think it's the things we spoke about, maybe modular designs at the beginning of a program, putting funding in place for the eventuality. You can't make obsolescence obsolete. It's always coming. So if it's something which is inevitable, then why would you not plan for it? So putting things in place to be able to react when obsolescence does come, but before that, talking to your valued supply chain to understand what value they can give in the meantime before obsolescence comes. Whether that's, we spoke about getting market data from different providers on the internet, giving years to end of life, or whether that's engaging with Rochester to understand market intelligence, what we see coming. We spoke about having not having a crystal ball necessarily, but we have a roadmap of technology that we're going to be building over the next 5 years. We have that roadmap because we see risk coming and we know we're going to need to support the market. So pulling that knowledge from the likes of Rochester and building that into either a plan for every part or that type of scenario on the bill of materials would be a great place to start from a design point of view.
In terms of just as a practical perspective, in terms of capturing that information and sharing it, is that still a kind of manual process? Are there software tools to help with that? Are there portals and things that customers can use?
Well, in terms of what we offer, it's knowledge, and it's knowledge and intelligence from our manufacturing team, from our supply chain team talking to the suppliers. So whereas you've got data, we're looking at intelligence, and that comes from people. There's a certain amount of tools that we can use to collate that and to reference it against certain parts, etc. But ultimately it's coming from our experience in the conversations that we're having in the market, which means that it's relevant and it's up to date, but it also means that it is slightly manual, and it's it's that type of activity for us. But there's also, that we mentioned the design side, but on the legacy support side, some of the tips that I would give is, again, engaging the supply chain. For example, if we were talking to a customer about a legacy design, one of the services that we would offer, and this isn't a paid for service, this is just us partnering with the customer, is to say, okay, here's your legacy bill of materials or your list of critical parts. Let us look at the stock that we have against those parts. Let us look against the where we can manufacture those parts, where we have the capability to manufacture those parts, and then let's look at the knowledge that we have, which might identify some risk in the future on these parts. Also, if we're talking about a legacy design, the chances are that the customer's already done last time buys. That's great. How long are those last time buys going to last? Because the process of dictating a last time buy is, it's the
forecasting.
Yeah, absolutely.
Really
how the last time buy process is normally driven by funding and what parts they can get for that funding. So getting it right is almost the impossible task. So for us to be able to look at where customers have already done a last time buy purchase, then look it up against our solutions, we can then give the customer an idea of, okay, if you run out of that last time buy stock, we then have a solution in place. Or we don't have a solution for everything. But just having that knowledge in the background can enable that customer to then go commercially to their team and say, we can sell X amount more systems of this because we know that we've got Rochester in the background who can continue to support. And there's also, when we're working with customers in advance and it comes to last time buy and we're talking about the critical parts, when it comes to the last time buy process, we can be in a position where we're talking to the manufacturer, understanding whether Rochester will have a manufacturing solution in the future, in which case is there a smaller last time buy that needs to be done for then to get to a point where Rochester can manufacture and deliver new parts, new day code products for the life cycle of that program. Or is the customer going to do a last time buy with their existing supply chain and may need the support in 10 years? All of this data that we can get part number wise from the customer can really drive our investments, and the chances of us having a solution in the future just grow exponentially compared to getting a phone call in 5 years' time saying, we did last time buy, we've already run out, we need another 10 years of stock.
Yeah, it's panic at that point. And that's the other element of it, is that without having that data ahead of time, you end up, the customer looks and says, well, I've got two options. I do last time buy and a redesign. Whereas actually we wedge ourselves in the middle of that, not to negate either of those, but the situation means that it allows us to offer future solution for them. Critical parts is critical because it's critical for the customer and it's critical for us to understand where we go with this moving forward. We do exercises with the customers, as Luke said, about give us your critical parts list, let's see what we hit. We've had huge hit rates with the customer, surprising to the customer of how, we don't do everything for everyone, right? We can't. but it's surprising the number of hits that we do get, which means actually they don't need to worry about that whole section of board because they know that we have it covered, and we can work with them on that. It means then they can concentrate on the other bits that might cause them problems, rather than having a panic when it comes to the end and it's like, these are now 20 years out of date, what do I do? So it's all about, you're designing for obsolescence, you're planning for obsolescence, and for us, we're in a really, really strong position to help support the customer, moving forward with their design.
So I'm going to try and summarise this entire conversation now. See how I do.
Good luck.
So it's an early engagement. We'll start there. That seems sensible and relatively simple thing to do, to put in a call, to see you at an exhibition, whatever. At that stage, to try and identify critical components. I guess that's a moving beast. Some may become less critical, some may become more critical. And one of the ways to do that is to leverage your knowledge, because you're talking to the manufacturers, you have a front foot on that. Practical work at the early stage, I guess, is, as you say, increasing modularity, design for disassembly, etc. So when the practical aspects of managing that appear, you're already ahead of the game. I see the service you provide as essentially a bridge. That's probably the best way to describe it. A bridge from the end of a semiconductor's natural life through to any future you wish. Be that a modest future from last time buy, or a much more grandiose future through remanufacture, if that's a fair description. Collaboration, information sharing,
very important.
all those good things that people are encouraged to do. So that sounds like a pretty straightforward checklist that I would recommend, and I can't see any reason why a design team wouldn't want to implement something like that straight away. It's a fairly low risk thing to do.
And I think they don't have to take the next step, the obsolescence step alone. I think that's the key. Whether it's Rochester or any of their other partners, and as I said before, getting the right value out of the partners, but they don't need to go through the journey alone. And there's things that they can do now which don't cost a thing, other than the transfer of data, part numbers under NDAs and all whatever needs to happen, to increase the chances of longevity and sustainability moving forward.
Yeah, fascinating. So yes, NDA, share some information, absorb some knowledge, and prep for the future. I think that's a good conclusion.
Simple.
Is that simple?
Wonderful. Thank you very much. Fascinating discussion. One hopefully of many.
Appreciate it.
Great to speak to you.
Thank you.